Hi guys, I'm Nivita. In this video, we are going to see inner product space, which is based on linear algebra. Okay, a vector space VF is called inner product space. Okay, if there is a function V cross V, it maps to F. Okay, satisfying the following axiom: F is a field. So there is a function which maps V cross V to F. Okay, it should satisfy the following axioms. So consider in the vector space we are having three elements like u, v, w belongs to v. Okay, and alpha comma beta are the two numbers. These are vectors, and the alpha comma beta are constants which belongs to the field. Then f of u comma v is equal to f of v comma u bar, complex conjugate of v comma u. Okay, so bar represents complex conjugate. You have to take conjugate for the complex numbers, which is suppose if it is I means you have to convert it like minus I. Okay, then f of u comma u should be greater than or equal to 0. F of u comma u is equal to 0 if and only if u is equal to 0. When u is equal to 0, f of u comma u will be equal to 0. Okay, then f of alpha u plus beta v comma w will be equal to, okay, this is like linear operation. So alpha into f of u comma w plus beta into f of v comma w. Okay, when the function satisfies this three property, that function is known as inner product space of v. Understood? Yes. Then notation: f of u comma v is generally denoted by the one of the symbols, like you can use it like u comma v, u dot v, like this, uv. Okay, v is equal to r power n of r, which is a real numbers. Okay, real numbers of n dimension. Okay, comes under the field is also a real number. Okay, then suppose if v is equal to r power n of r, then inner product of x comma y will become xy transpose, which is equal to y transpose into x, is called standard inner product of v. Okay, so inner product we can mention it like xy transpose is equal to y transpose x, which is known as a standard inner product of v. Then u comma v is equal to UTAV is a inner product if and only if A is symmetric and positive definite. Here this A, no, this is matrix. A is a matrix. A is a matrix which is symmetric as well as positive definite should come. Okay, then we can write this inner product as U transpose AV. Understood? Yes. When you see by a problem, you can easily understand what they are telling. Inner product we can write it as U transpose into AV when A is symmetric and positive definite. Okay, we will see one example question. V is equal to, that is vector space is equal to r power n. A belongs to the matrix of order n, and that matrix of element should be r. Okay, then the inner product. The inner product space is from V cross V to R. Okay, such that x comma y of A is equal to ax comma ay is a standard inner product. They are telling it is a standard inner product if and only if they have given four condition. We have to check what are the condition will satisfy. I already told you standard inner product means, okay, standard inner product means xy transpose is equal to y transpose x, right? So I can take it like xya, here given as xya, which I can which is equal to inner product of ax ay. Okay, so if it is a standard inner product, then I can take it as y transpose into x. Here y transpose is y is ay transpose into x is ax, right? So if you apply the property of AB the whole transpose, you will get like B transpose into A transpose. Like for that we will be getting Y transpose into A transpose into AX. Understood? Okay, fine. Here if A transpose A is positive definite and symmetric, if A transpose into A is positive definite and symmetric, okay, we will check. Suppose if you are considering A is equal to 1 0 0 minus 1 is indefinite, because when you are considering d1 means this element alone, which is greater than 0. But when we are considering d2 means you have to find determinant for this 2 by 2 matrix. You will get the value which is less than 1. less than 0 because negative value is coming. When it is an opposite symbol, it is known as indefinite. Okay, so if A transpose into A is positive definite and symmetric, they are telling. So if you find A transpose, okay, if you find A transpose, what you will get? Again 1 0 0 minus 1. A transpose means changing of row and column. 1 0 0 minus 1. If you multiply this A and A transpose, you will be getting this value. Okay, this value is obviously a positive definite because positive definite means D1, the first element alone, is greater than 0. D2 means taking determinant for 2 by 2 matrix, which is also greater than 0 because 1 into 1 is 1. Okay, that is positive definite. When this A transpose into A is positive definite and as well as it is symmetric. Symmetric means what? Leave the diagonal elements, remaining Aij is equal to Aji. Here it is A12, here it is 21. A21. These two elements are equal. Okay, no need to say you should not consider A alone. Okay, A transpose into A you have to consider. Understood? When that whole element, okay, is a positive definite as well as symmetric, then we will say it is a standard inner product. Understood? Fine. Okay, then C and D are incorrect because A is positive definite they have given, but here A is indefinite. Okay, A is positive semi definite they have given, but here it is indefinite coming down. So C and D are incorrect. So A into A transpose should be like positive definite should come. Okay, we know that A transpose into A is positive definite. Positive definite means what? If you find eigenvalues for A transpose into A, all eigenvalues will come like positive. Okay, positive and non-zero will come. Then non-zero means determinant will become non-zero. When all the eigenvalues are non-zero, obviously then the determinant will become non-zero. Non-zero means what? It is a non-singular, that means A inverse exists, right? So therefore it is non-singular. Then you can tell like row of A is equal to nullity of A. Row of A is equal to nullity of A. How? When A is non-singular, obviously we can say like row of A is equal to nullity of A. So option B is correct. Okay. Here nullity of A is actually 0. Okay, here nullity of A is actually 0 because when you are considering it, that we don't have a row which is full of 0, so nullity of A is 0. Okay, so we can say like kernel of A as 0. Why? Kernel means what? Actually kernel refers to a linear transformation where see here, kernel of T is equal to ABC. When we apply transformation for the ABC, it will maps to 0. Okay, those elements will be considered as kernel of T. Here we don't have any rows which is completely 0. Therefore, the nullity of A is 0. Okay, so there is no element. There is nothing. Okay, nullity is 0 here. Therefore kernel, we can't say any element that maps to 0, so kernel is also a 0. Okay, so option A is correct. This is here option A and option B are correct. Positive definite and positive semi definite is wrong. So the thing is, you can take another example and you can tell for this A comes under positive definite. Like you can say like A is a positive semi definite, but you have to prove it for each and every matrix. Okay, so I'm taking one matrix which is not positive definite, which is indefinite, and I'm telling like, okay, A is not a positive definite, A is not always a positive semi definite. Okay, so you have to consider this thing. Here what they have given is UTAV, right? That inner matrix should be symmetric and positive semi-definite. So here that inner matrix should be positive and semi-definite. So here that inner matrix is A transpose into E, that is positive definite as well as symmetric, so it is an inner product space. Okay, as well as row of A is equal to nullity. Here nullity we don't in the matrix say no, so nullity is 0 because the rank of A is 2. So therefore the kernel will not come, so therefore the kernel is 0. Thank you for watching.